Before diving into training machine learning models, it might be useful to have a look at the bigger picture, that is, at the whole process behind a data analytics solution. The process is actually quite old and established by now. It was formalized under the name of CRISP-DM process. CRISP-DM stands for Cross-Industry Standard Process for Data Mining. While the whole discipline name has changed over the years from data analytics to data science, and it will probably change more in the future, the underlying process has not. Let's have a look at it. A data analytics project always starts with some data lying around in some repository. No data, no project. The first step is then to access this data from a file, from a database, from a REST service, from a document, or from whatever other source in public or private mode. With the plethora of data available more or less for free on the internet, it's nowadays always possible to enrich your original data set with additional related data. It is also possible that additional related data are available within your company in different shapes or form. So the next step after reading your data will probably be to hunt down additional related data to enrich your data set with hopefully useful information. This phase is known as data blending. At this point, the data set is ready for preprocessing. This includes the creation of new features. Usually, those are domain-dictated features to better describe the problem. For example, in customer intelligence, those might be behavioral features. Each domain suggests the kind of new features to create. This also includes dimensionality reduction. Of all the input variables we have got, which ones are really useful? Which ones contain useful information? Imputing missing values. Missing values is still a big topic in data analytics. What do we do with records including missing values? Also here, many strategies are available. Most of them are implemented in the missing value node in Knime Analytics platform. Outlier removal and record number reduction are also a part of the data preparation phase. General data manipulation. This part prepares the data to best fit the machine learning algorithm to come. If we are dealing with supervised machine learning algorithms, partitioning is in order to create a training set and a test set. Remember that in this case, all data transformation should be defined on the training set and only applied on the test set. Now that the data is in the form and shape we wished for, we can start with building and training models to perform a specific predictive task. Here we can use traditional supervised training algorithms like neural networks or decision trees or naive bayes or some clustering techniques. If we are not sure of which algorithms will perform best, we can train a bunch of them. That would be a bag of models. And then we compare the results and we choose the best performing model. This is how it used to be traditionally done. Lately, we stop making the algorithms compete and instead we ask them to cooperate. Ensemble models were born. You can use pre-packaged ensemble models like random forest or deep learning, or you can even make your own ensemble model. You can also train a clustering model if your use case does not require supervised training. Or you can generate new different models automatically, moving from a bag of models to a model factory. Once you have trained your model for the first time, you can now tune some of its parameters in the hope of getting better results. You can do this manually or automatically. In the first case, we have a parameter tuning phase. In the second case, a parameter optimization loop. Once you have a model that you think it is right, you need to evaluate its performance, and this is the model evaluation phase. Many measures have been created over the years to evaluate model performances. That is, to evaluate how good the model performs on unseen data. Most of these measures rely on the confusion matrix of the model predictions or on some distance between the real values and the predicted values. The last phase of this whole process is deployment. Deployment has been separated by the rest of the cycle by this red dotted line here. This is because deployment takes the model, once its performance has been judged acceptable, and throws it into the real world, with real-world data, that is, into production. We can write the prediction results onto a database or a file. We can display the results in flashy dashboards or on paper reports. We can expose them via REST API. We can generate them by transforming the model into SQL code, and we can use them in many other ways. Here I end this video. I hope it has given you a more clear, higher level picture of all the activities, recursive and one-time only, involved in a data science project.